So in this video we will study about how to calculate the KSP or solubility product for some salt. So KSP is not the same as the solubility. Solubility is different than the solubility product. Solubility is the generally expressed as the mass of the solute dissolved in 1 liter or in 100 ml. Basically unit will be like gram per ml or gram per liter of the solution or in the molarity. And regarding the solubility product, what we have to do, we have to find out the mass solubility of compound in gram per liter using the formula weight. We can convert them into molar solubility of the compound, mole per liter, then using the empirical formula, molar concentration of the ions, and then we can find out the solubility equilibrium. So this is the path, this is the flow chart we are going to use this one. And then let's solve few examples to understand this formula. So here is this question that a saturated solution of magnesium fluoride in contact with the undissociated solid is prepared at 27 degrees Celsius. The concentration of magnesium ion in the solution is found to be 1.2 times 10⁻³ molar. What is the value of KSP for the magnesium fluoride at this temperature? So first of all we have to find out what is the information is given here. So first information they are asking KSP, they are asking, and magnesium fluoride is the compound. And if we have to dissociate magnesium fluoride into ions, so basically it will dissociate into magnesium plus 2 and plus there will be 2 fluoride ion, right? So this will be in the aqueous, ions will be in the aqueous condition, and then this is the solid. And then magnesium concentration is given, Mg plus 2 is given here, which is 1.2 times 10⁻³ So how we are going to calculate this? So I have already solved here, we'll use this slide. So once if you see this stoichiometry of this reaction, basically magnesium fluoride will dissociate into magnesium ion and fluoride ion, 2 fluoride ion. So each magnesium, if we have 1 mole of magnesium fluoride, I will get 1 mole of magnesium ion and 2 moles of fluoride ion. So in the question they are saying that we are getting 1.2 moles of the molarity of magnesium ion is 1.2 times 10⁻³ So the molarity of the fluoride ion will be just double of this one based on the stoichiometry of the solution. So the molarity of the fluoride ion will be 2.2 multiplied by 1.2 times 10⁻³, which is this one. And how we are going to ionize this formula, which is written here, we have to use the crossover rule to ionize this ionic magnesium fluoride. Now once we will write the KSP value, so KSP will be equal to magnesium ion fluoride ion raised power 2, this coefficient will go as a power. Then we will write the molarity concentration of magnesium ion, which is 1.2 times 10⁻³ and multiplied by 2.4 times 10⁻³ raised power 2. So the KSP once we will solve, it will become as 7.0 times 10⁻⁹, and there will be no unit. So this was the example for the magnesium fluoride KSP. Let's see the another question, which is here, that the copper nitride, the KSP is given. Here they have given KSP for the copper nitride, and what is the solubility of water in the gram per liter. So now they are asking what will be the solubility. How we are going to solve this question? So we will solve this question like this, that first copper nitride we have to dissociate into ions. So in the aqueous ion will have one copper ion, and there are two nitrite ion. No, basically this will go to here. Copper will have -1, so 2 copper and 2 2 plus ion on the copper, and nitride have -1, and there are 2 nitride ion is required. So Ksp value is already given. So Ksp value is already given. We will write the first Ksp product, and the molarity or molar ratio, if you see, 1 mole 1 mole 2 mole, right? So we can suppose we can write here, if we have x mole, then we'll get x mole of copper and double x mole of nitride ion. So Ksp for this copper nitride will be x and 2x raised power 2. So here will be x, and once you will open this parenthesis, this become 4x power x raised power 2. Then x multiplied by x raised power 2 will become x raised power 3. Then from here we can calculate the x value, which will be 4x cube equal to Ksp, and x cube will be Ksp over 4. Now we know the Ksp value, so we can plug that value into this formula divided by 4, and then once we'll solve this, then we have to take 3 under root, right? So here if you will take under root of on this side, basically we have in the calculator you have to take 3 and under root. So 3 under root will solve the problem, and we will get this x rather than x cube. So from x cube to x you have to take 3 under root, and then once we'll take 3 under root, which is basically like 1 over 3 power, and if we are taking 1 over 3 power, we can calculate the x amount in the molarity, this much. So if we know the x value, it means we know the molarity, means this will be mole per liter, and now we have to convert into gram per liter, because in the question they are asking what is the solubility of copper nitride in the water in gram per liter. So what we can do, we have to find out the molar mass of or formula weight of copper nitride. So copper nitride is 147.58. how we can calculate? This is the molar mass calculation you can look at, and once we know the molar mass, we can multiply by the molar mass with this mole, and to get the solubility of copper nitride, since we are getting x, so x will represent either the copper ion or copper nitride both. If we have to find out the concentration of nitride ion, so it will be like a just double of this x. So these were the two examples for Ksp related, and in the next video we will study about the effects of different factor on the Ksp.